Welcome to the deep dive. Today we're getting right into the core of modern web development, React.js.
Mm.
This is really about giving you a shortcut, a way to grasp the essential building blocks.
Yeah, the why behind them too.
Exactly, and how they let you build these, really solid web apps. So whether you're maybe just starting out or perhaps brushing up for a tech interview.
Or even just curious.
Right. We want to unlock those key aha moments for you, but without drowning you in information.
And what's really cool about React, I think, is how all these different pieces, components, the virtual DOM, hooks, they all kind of fit together
Right.
to create something, well, pretty powerful for building UIs.
Yeah.
So our goal today is really to extract those crucial bits of knowledge from the material we've looked at.
Helping you build that mental map of how React works.
Exactly. And maybe why it got so popular in the first place.
Okay, so let's start broad. What is React fundamentally? Why is it such a big deal?
Yeah. Well, at its heart, React is a JavaScript library. Its main job is building user interfaces. It's primarily backed by Meta, Facebook.
Right.
But it's more than just a library. It really changed how developers thought about building UIs. It pushed this idea of declarative programming.
Declarative. What does that mean in practice?
It means instead of telling the browser step by step how to change things like find this button, change its text, update that list, which gets really complex.
And error prone, I bet.
Totally. Instead, you just describe what the UI should look like based on the current data. React figures out the how part efficiently behind the scenes.
Ah, okay. So you say, show this, not do this, then that.
Precisely. And this is built around its component-based structure and this really efficient rendering system it has. That's what makes building complex stuff faster and, well, easier to manage.
That makes sense. Moving from how to what, you mentioned components. They sound pretty central. Tell us more about those building blocks.
Absolutely. Components are like the atoms of a React app. Think of them as self-contained little pieces of UI.
Like Lego bricks.
Sort of, but maybe smarter Lego bricks. You define them once, maybe a button or profile card, and then you can reuse that same component everywhere you need it.
Ah.
And that's where the modularity really helps, especially when you're building big applications. Makes the code much easier to handle, much more scalable.
And I gather there are different ways to write these components.
Yeah, mainly two types you'll hear about. First, functional components. These are basically just JavaScript functions.
Simple enough.
They used to be simpler, yeah, mostly for presentation. But then hooks came along, and now they can handle state and side effects. They're pretty much the standard way now.
Okay. And the other type?
Class components. These are built using JavaScript's ES6 classes. They have these built-in methods called lifecycle methods, which give you really fine-grained control over what happens when a component mounts, updates, or unmounts.
So more control, but maybe more complex.
A bit, yeah. They're still around and supported, but for new stuff, most folks lean towards functional components and hooks because they tend to be a bit cleaner and easier to reason about.
Okay, that makes sense. And that brings us to something you mentioned earlier, this efficiency engine, the virtual DOM. This sounds like a key reason React is so fast. How does that work?
Right, this is a really clever part of React. The virtual DOM is basically a lightweight copy, an in-memory representation of the actual browser DOM.
The real web page structure.
Exactly. Now, directly manipulating the real DOM is slow, very slow. So React avoids doing that directly whenever possible.
Okay, so what does it do instead?
When something changes in your app, say, some state updates, React first creates a new virtual DOM tree reflecting that change. Then it compares this new virtual DOM tree with the previous one it had stored. This comparison process is called reconciliation.
So it's like playing spot the difference, but for code.
Yeah, pretty much. A very fast, efficient game of spot the difference. And based on that comparison, it figures out the absolute minimum set of changes needed to make the real DOM match the new state.
Ah, so it doesn't redraw everything.
Exactly. It only touches the specific parts of the real DOM that actually changed.
Huh.
Maybe just updating the text in one paragraph or adding a single list item.
Right, instead of throwing out the whole page and rebuilding it.
Precisely. This targeted approach makes a huge difference in performance, especially for complex UIs with lots of updates. It makes the app feel much smoother and more responsive.
That's fascinating. It's a core reason for React's performance edge then. Now, you mentioned hooks transforming functional components. What was the big problem they solved? Why were they such a big deal when they arrived?
Yeah, hooks were a major shift around React 16.8. Before hooks, functional components were primarily stateless. If you needed state data that changes over time or lifecycle features, you had to use a class component.
So you'd often end up converting components.
All the time. Or you'd end up with these complex layers of components just to pass data down, sometimes called wrapper hell. It wasn't ideal.
Yeah.
Hooks provided an elegant solution. They let you hook into React's state and lifecycle features directly from within functional components.
Without needing a class.
Exactly. It meant you could keep your components as simple functions, but still give them powerful capabilities, like managing their own state or running code after they render. It made component logic much easier to reuse and compose.
That sounds much cleaner. So what are the main hooks we'd typically run into?
The absolute workhorses are useState and useEffect.
Yeah.
useState is for adding local state to your component, think counters, form inputs, that sort of thing.
Okay.
And useEffect is for handling side effects. We can dig into that more later. But it's for things like fetching data, subscriptions, timers, basically anything that interacts with the outside world.
Got it. And there are others too.
Oh, yeah. Use context for sharing data without passing props down manually. Use ref for accessing DOM elements directly or storing values that don't trigger re-renders.
Yeah.
Use memo, use callback for performance optimizations. Quite a few tools in the toolbox.
All right, let's shift gears slightly to syntax. JSX. It looks like HTML inside JavaScript. What's the story there?
Right. JSX stands for JavaScript XML, a syntax extension, basically syntactic sugar. It lets you write something that looks very much like HTML right inside your JavaScript code.
But it's not actually HTML.
Nope. And it's not standard JavaScript either. It's a special syntax created for React, although other libraries sometimes use similar concepts. The idea is to make describing your UI feel really natural and intuitive.
It definitely looks more readable than, say, creating every element with function calls.
Exactly. Imagine building a complex form using only React.createElement nested calls. It would be a nightmare to read and write. JSX makes it look familiar like the HTML structure you want, but you can embed JavaScript expressions right inside it using curly braces.
So you get the best of both worlds. HTML-like structure, JavaScript power.
That's the goal. But crucially, browsers don't understand JSX out of the box.
Ah, right. So how does that work?
You need a tool in your build process, usually Babel, to transpile the JSX code. It converts the JSX syntax into regular React.createElement calls that browsers can understand.
Okay, so it's a development convenience that gets compiled away.
Precisely. Makes developers happier without changing what the browser ultimately runs.
Got it. Okay, let's dive into how data moves around in React. This seems crucial. The difference between props and state.
Absolutely fundamental. If you get this distinction, you're well on your way to understanding React's data flow. Let's start with props.
Okay.
Think of props short for properties like function arguments. They are how components talk to each other, specifically how a parent component passes data down to its child components.
Passing data down. Got it.
And the really key thing about props is that they are read-only or immutable from the perspective of the child component receiving them. The child can read the prop, use it to render something, but it cannot change it directly.
So the parent dictates, the child listens.
Kind of, yeah. It enforces a one-way data flow. Data flows down.
Okay, so that's props. What about state?
State is the component's internal memory. It's data that the component owns and manages itself. Unlike props, state is mutable. It's meant to change over time, usually in response to user interactions or network responses.
So if a user types into a search box, that changing text would likely be state?
Exactly. That input value is internal to the search box component. When the state changes, maybe using the useState hook we mentioned, React knows it needs to re-render that component to reflect the new state.
And that re-render might then pass down new props to children.
Precisely. State changes trigger re-renders, which can then cause new props to flow down the component tree. Understanding this interplay props down, state internal state changes trigger updates is key to everything.
Props versus state. Immutable downflow versus mutable internal data. Makes sense. Let's revisit useEffect. You said it handles side effects. What exactly counts as a side effect, and how does useEffect manage them, especially with that dependency array?
Right, side effects can be a bit tricky. Basically, a side effect is anything your component does that affects something outside of itself. It's not just calculating and returning JSX.
Like talking to a server.
Exactly. Making API calls is a classic side effect. So are things like setting up subscriptions, manually changing the DOM outside of React's control, setting timers with set timeout or set interval.
Things that interact with the world beyond the component.
useEffect is the designated place in functional components to perform these actions. By default, the code inside useEffect runs after every time the component renders.
After every render. That sounds like it could happen a lot.
It can, and that's where the dependency array, the second argument to useEffect, becomes absolutely critical. It lets you control when the effect runs again after the first time.
How does that work?
If you pass an empty array, the effect runs only once, right after the component mounts initially. Perfect for setup tasks like fetching initial data.
Okay, once and done.
If you put variables inside the array, say userAdd, the effect will run after the initial render and any time the value of userID changes.
So it reruns only if specific data changes.
Incorrect. And if you omit the dependency array altogether.
It runs after every single render.
Yep. Which is sometimes what you need, but often leads to unnecessary work or even infinite loops if the effect itself causes a state change that triggers another render. Mastering that dependency array is key to using useEffect correctly and efficiently.
Very important detail. Okay, so as apps get bigger, we have lots of components. Sometimes different components need the same data. How do we handle that without making a mess? There's a pattern called lifting state up, right?
Yeah, exactly. This pattern addresses the common scenario where several components need to reflect the same changing data, or when a child needs to communicate back up to a parent.
So if maybe two different sections of my UI need to display the user's name.
Right. Instead of each section trying to manage its own copy of the user's name, which could get out of sync, you lift that state up.
Lift it where?
To their nearest common ancestor component in the tree. That ancestor component then becomes the owner of that state, the single source of truth.
Okay. So the parent holds the name state.
Correct. And then it passes a name down as a prop to both sections that need to display it. If the name needs to be changed, say by a form in one of the children, the child calls a function, also passed down as a prop, that actually updates the state in the parent.
So data flows down, but change requests flow up via functions.
You got it. It keeps the data flow predictable and ensures consistency. Lifting state up is a fundamental pattern for structuring React applications, especially as they grow in complexity.
Makes sense for keeping things organized. Now, for navigating between different pages or views in these apps, especially single-page apps, we usually use something like React Router.
React Router is the de facto standard library for handling routing in React applications. It lets you create that seamless navigation experience where the URL changes and the content updates, but the whole browser page doesn't do a hard refresh.
Right, keeping it feeling fast and app-like.
Exactly. It allows you to map different URL paths to different React components. So dashboard might render your dashboard component, profile renders the profile component, and so on.
And it handles things like parameters in the URL. Like users.useri.
Yep, it can parse URL parameters, handle query strings, manage nested routes, programmatic navigation. It's quite powerful.
What are the key pieces you usually work with?
Typically, you'll wrap your app in a browser router. Then you define your routes using the route component, specifying the path and the component to render. For links, you use the link component instead of a regular nanic to prevent full-page reloads.
And for navigating programmatically, like after a form submit?
There's a hook for that now. Use navigate. It gives you a function you can call to change the URL from within your component logic.
Cool. Okay, one last core concept. Handling form inputs. Forms are everywhere. How does React typically manage them? You mentioned controlled components.
Yeah, the most common pattern in React is using controlled components for forms. It sounds fancy, but the idea is simple.
Okay.
Instead of letting the HTML input element manage its own internal state, like what you've typed into it, React takes control. The value displayed in the input field comes directly from the component state.
So the input value is set from React state.
Exactly. You'll have a piece of state, maybe using useState,
Yeah.
that holds the current value of the input. You pass that state variable to the value prop of the input element.
Okay. But how does it update when the user types?
That's the other key part. You also provide an onChange event handler to the input. When the user types, onChange fires, inside that handler function, you update the React state with the new value from the input.
So user types onChange fires, state updates, React re-renders, input shows the new value from state.
Precisely. It creates this loop where the React state is always the single source of truth for the input's value.
Why go through that trouble? What's the benefit?
It gives you complete control. Because the value is in your state, you can easily validate it on every keystroke, format it, disable a submit button based on it, react instantly to changes. You always know exactly what the form data is because it's right there in your component state. It makes forms much more predictable and easier to manage within the React paradigm.
Controlled components. Got it. That makes a lot of sense. We've covered a ton of ground, the basics, components, virtual DOM, hooks, data flow, routing, forms. That's a solid foundation. But what about leveling up? What are some of those extra insights for building really solid apps?
Right, moving beyond the fundamentals. Performance is always a big one. We touched on the virtual DOM, but sometimes you need more. That's where memoization comes in.
Memoization.
Yeah, basically caching. Tools like React.memo for wrapping components or the use memo and use callback hooks help you tell React, hey, if the inputs haven't changed, don't bother recalculating this value or re-rendering this component.
Skipping unnecessary work.
Exactly. In complex apps, this can save a lot of wasted rendering cycles. And for really big lists or data grids, techniques like virtualization using libraries like React Window are crucial. They only render the items currently visible on screen.
Smart. What about when things go wrong? Error handling.
Good point. You don't want one small error in a component to crash your entire application. React has a concept called error boundaries. Historically, these were done with a special lifecycle method component did catch in class components.
And what do?
They act like try-catch blocks, but for components. If an error occurs anywhere in the component tree below an error boundary, the boundary can catch it, log it, and display a fallback UI instead of just showing a broken app. It helps contain the blast radius of errors.
Making the app more resilient. Okay. And what if lifting state up gets really cumbersome, like passing props down 5 levels?
Yes, prop drilling. That's where the Context API really shines. It's React's built-in way to share state that can be considered global for part of your component tree without having to pass props down manually at every level.
Like user authentication status or theme settings.
Perfect examples. You create a context, provide a value at a higher level, and any component deep down in the tree can consume that value directly. It's much cleaner than prop drilling for certain types of state.
Handy. And briefly, any tips on API call strategies?
We mentioned using useEffect for calls on mount, definitely. The key is always handling loading states, showing a spinner perhaps, and error states, displaying an error message. Don't leave the user guessing.
Good UX practice.
Absolutely. Libraries like Axios can make the actual HTTP requests a bit easier. And for more complex scenarios involving caching, background updates, synchronizing server state, libraries like React Query or SWR are incredibly powerful and worth looking into. They handle a lot of the complexity for you.
Wow. Okay, so from the core ideas like components and the virtual DOM through hooks, state management patterns, routing, and even into optimization and error handling, we've really covered the landscape.
Yeah, I think understanding these pieces gives you a really strong foundation, whether you're actively developing, managing developers, or just trying to understand how modern web apps are built.
It provides that crucial mental model.
Definitely. But, the theory is one thing. The real understanding, the deeper learning, that comes from actually building stuff.
Right. Getting your hands dirty.
Exactly.
Yeah.
Don't just memorize useEffects rules. Build a component that fetches data. Struggle with the dependency array. Debug it. That's when it really clicks.
So try building small projects.
Absolutely. Break things. Fix them. Explore the ecosystem beyond core React. Yeah. Maybe look at state management libraries like Redux or useState if your app grows complex. Or check out frameworks like Next.js or Remix that build on top of React.
So the final thought really is about application, isn't it?
I think so.
Yeah.
It raises that important question for anyone listening. Now that you have these insights, how are you going to apply them? What will you build next?